In this video, I'll be struggling onwards with the installation of Soft Landing Linux System, or SLS, that I made back in the 1992 season. But first, let's have a look at what's been going on in Linux land during 1993. After the release of 0.99 in late 1992, Linux version 1.0 seemed to be just around the corner. So, 1993 is the year we finally get the big 1.0, right? Nope. Some highlights. 0.99 adds NFS support, which is a Unix network file system, and it also adds the make config command for compiling the kernel. 0.99.1, or patch level 1, adds extended virtual consoles, which allows for switching between X11 and text mode. Patch level 2, executables can now run from file systems without BMAP support, for example the MS-DOS FAT file system. At patch level 3, 1.0 seems to be just around the corner still. Patch level 4 fixed an interesting system lockup, where moving the mouse would crank the system forward. It was an interrupt issue. By patch level 5, Torvalds had no idea when 1.0 was going to be released. Patch level 6 adds support for compressed kernel images. With patch level 7, the ext2 file system is now in the kernel. Older ext volumes smaller than 256 MB will be converted automatically on mount. SHIA-FS is also in the kernel. Patch level 10 has a new network stack. The keyboard layout can now be changed dynamically, it's not just compiling to the kernel. And the System 5 inter-process communication patches, required by dosemu, is now in the kernel. In patch level 11, Linux is switching to C++ for better type safety. In patch level 12, the Sony and Mitsumi CD-ROM drivers are now in the kernel. In patch level 13, Linux is no longer C++. Support is added for ELF binaries. And finally, patch level 14, swap partitions can now be larger than 16 MB. Sun drivers are now included with the kernel, and a drivers directory in the source tree is created, which we all know and love to this day. In general, there was also a push towards removing all dependencies on FreeBSD specific features in the kernel in order to make porting it to other CPU architectures possible. By the end of 1993, this had more or less completed, and work had started on porting Linux to the Motorola 68000 and MIPS CPU architectures. As far as distributions go, there's a few new ones popping up. Slackware first released in July 1993 as a response to the buggy mess that was SLS. This is also when more CD-ROM distributions started showing up. Nascent and Unifix were two examples. Both can boot off the CD-ROM, but both can also install to the hard disk and load parts of the system off the CD-ROM as needed. There's also a few German distros I've seen mentioned, like DLD and LST. Information about these in English seem to be quite scarce, so I'm going to pass up on covering these in more detail. I did however note that LST aimed for stability rather than having the latest version of everything. A common focus of the European distributions was 8-bit clean software. A lot of software written up until this time had assumed the 8th bit of every byte in text strings was up for grabs to do whatever with, or that it was dangerous, or that it might not be present at all. Remember, 8-bit bytes only became popular in the mid-70s. Before that, and for a time after, you'd say octet if you wanted to be specific, which the French still do for some reason. With the many extended ASCII variations adding support for other languages, like ISO 8859, this had become an issue. This is the reason that email messages to this day are base64 encoded. For a long time, email servers just weren't 8-bit clean. Another innovation brought on by these CD-ROM distributions is IFS. IFS is a way to add a writable overlay to a read-only media like CD-ROM. Like SLS 1.02, which shipped on a CD-ROM with the IFS patches built in. Also worth mentioning is Tamu, which has once again switched up their foundations and is no longer built on SLS with its September release. Instead, it's using an integrated source tree, allowing the entire distribution to be compiled from a top-level makefile. In the mainstream computer magazines I read, all based in Sweden, I didn't really see any mention of Linux, aside from this one mention in the reader's question section. The focus instead seemed to be on how Unix should meet the threat from Windows NT, which launched in 1993 and offered Unix-like performance and stability on a Windows platform. So, what's the agenda for today's video? Well, first of all, I'd like to be able to boot into my install without having to use a boot floppy. I'd also like to get my new shiny CD-ROM drive working. And finally, I want to give the latest version of dosemu a look. And I also want to keep using my sound card. As a reminder, these are the specs of the computer I'm using. Aside from Linux, I also got MS-DOS 5.0 or Windows 3.1 installed. Anyway, let's get started. First, I'm going to deal with the boot issue. I've already had enough trying to get Lilo working, so I'm going for a different approach. There's a utility that can boot into Linux from MS-DOS. It does however have a limitation, and it needs to be loaded below 64K to function. To accomplish this, it needs to be the first thing that is loaded. This is done by using it as the shell instead of command com. So the recommended utility to pair it with is the shareware utility called bootsys. It lets you create a boot menu, which will load different configsys and odd exec paths variants. The built-in support for this in MS-DOS didn't arrive until MS-DOS 6.0, which I'm not running. This allows me to create a boot option that doesn't load any drivers and just jumps straight into the Linux loader. So, now that I can boot my system without a floppy, how will I get the CD-ROM working? I'm going to need to upgrade my kernel, and there's a lot of choices here. One limitation I have to take into consideration though, is that my install is both outdated and a bit broken. I'm also almost out of disk space, so I can't really upgrade GCC or install new libraries. I have GCC 2.2.2D, which is not able to compile anything newer than patch level 9. The Mitsumi CD-ROM driver entered the kernel in patch level 12, but there is an out-of-tree patch for patch level 9, so that's fine. Inter-process communication patches were annoyingly enough mainlined in patch level 10, and out-of-tree patches don't apply cleanly to patch level 9. It's supposed to be possible though. I can also find a sound driver patch for patch level 9, so that's great. So that settles it really. Patch level 9 is the newest I can run, which was released in April 93. I'll start with adding sound drivers to my kernel. New with kernel 0.99 is the configuration script, which lets you configure your kernel by answering questions. Last time this was all in a makefile. The chosen keyboard layout is still in a makefile though, as that wasn't changed until patch level 10. This version of the kernel already have configuration options out of the box for the sound drivers, so I just need to unpack the source code and configure the kernel. And instead of having to input this information into a header like last time, configuration script asks me for the IQ settings. No patching needed. I still need to work around my incomplete system though. After fighting a bit with the CD-ROM file system driver needing SCSI support, I'm booting into the new kernel. It detects the sound card, and a quick test tells me that it's working. Time for CD-ROM. The CD-ROM drivers come as a single source file and a patch. It is at this point that I discover my broken system doesn't have a patch utility either. I'm sure it wouldn't apply cleanly anyway, so I applied the patch manually. It was a fairly large amount of small patches to apply, and I had to retry recompiling the kernel a few times due to my typos. But in the end I got there. But with that, and another reboot later, Mitsumi CD-ROM drive present. Aside from a few temporary brain farts trying to remember the file system name to use when mounting the volume, it all just worked. Before playing with the CD-ROM drive more, I wanted to have a closer look at updated sound drivers. Did they fix the broken MIDI playback? No, but it's different this time. PCM playback is still fine though, with a slightly lower sample rate in this version of the utility. With sound confirmed good, I wanted to get audio CDs playing. There were a number of utilities for this, some of which were graphical, so I jump into X Windows for that. I have to apologize here, I only have potato camera video for this section of X11. The new kernel uses 800x600 timings that are almost but not quite the same as my X11 timings, so the capture just failed here. First, I tried something called XCD Player from late 92. It seems like it was only designed for SCSI CD-ROM drives, and it wasn't compatible with my Mitsumi drive. So next I tried Workman, another graphical program which seems to be the contemporary preferred choice. That too failed, as I didn't have the XView libraries needed to build it. In a last-ditch attempt to get it working, I found a command line utility that the author had claimed to have written for their own Mitsumi drive. I couldn't run the included binary, as my C runtime library is too old. Outdated libraries is a constant struggle at this point. Linux was just moving too fast. After patching out some dodgy string handling that caused it to core dump on my system, I could hear the faint sound of success. After struggling a bit to get Xmix working, I was able to open up a sound mixer and open the tap, startling myself in the process. And that's what progress looks like. And since audio playback works, I wanted to give the data portion a closer look. Loaded in is Infomagic's December 1993 Linux CD. Here's a readme for Slackware 1.1.1, one of the many options I have for getting rid of this dumpster fire of a Linux install. Although I'm personally more excited about Debian, but that's not out yet. Anyway, finally I want to give dosemu a look, and step 1 is applying the inter-process communication patches. This turned out to be a huge set of patches. and they were all for an earlier kernel, so even with a patch utility, they wouldn't have applied cleanly. Eventually, my patience ran out and I decided to be without. These patches add something called shared memory and is used by dosemu for expanded memory emulation. I can do without that. Which brings me to compiling dosemu itself. So I started building dosemu 0.49, but I quickly ran into another issue. A compilation issue I couldn't wrap my head around. Defeated, I decided to give the version of dosemu included with my 1992 install of SLS a try. And it just crashes. This, in and of itself, isn't too surprising. I had heard that the version of dosemu shipped with early releases of SLS were broken and non-functional. So I decided to try some other versions, the 2 releases before the latest version of dosemu, 0.47 and 0.48. They both failed for me in the same way. I can compile them just fine, but I can't get them to see the MS-DOS system disk in my floppy drive. It doesn't even attempt to read it. Now, you can't just Control-C out of this emulator, which brings me to the next issue. Previously, when you recompile the kernel, you need to run ps-u to update some pointers into kernel memory for ps on top to read out the process list out of. However, this must have changed. My version of ps can't read anything that makes sense, other than the number of running processes perhaps. And when I went reaching for it, I don't seem to have a /proc. And since I don't know its process ID, I can't even kill the bork dosemu. Even more fun is that this kernel I'm running must have changed something else. Shutdown and reboot doesn't work anymore, so I don't really have a safe way to shut down the system. After meanly rebooting the system with Ctrl-Alt-Delete a couple times, I find out that procfs is a feature that exists. It was a new feature in kernel 0.98, which is what my copy of SLS shipped with. I guess it was new enough that it wasn't activated? I was able to mount it and figure out the process ID of dosemu that way. Still, I wasn't able to get dosemu to see my floppy drive. So the dosemu quest is a complete failure. At this point, I'm ready to accept that this dumpster fire of a Linux install had reached the end of the road. It's time to reinstall. I decided to save the install for posterity, so I started tarring up the root file system with the system still running on it. At this point, I was a bit confused with how tar's volume size option is specified. The first archive always seemed to be smaller than the second. Thinking that it's in kilobytes before compression, I go with 1200 and finally get the ball rolling. The first archive is smaller, but the rest of them is exactly 1200 kilobytes. This took a while, and at some point around floppy number 30, I'm starting to question the compression ratio of the old Unix compress. 2 hours and 51 floppy disks later, I'm done. Only to discover there's a bug in tar. Only the first archive is actually compressed. It would have been about 30 disks if all of them were compressed. Let's just say I was a little annoyed finding this out. I guess the door hit me on the way out. Anyway, I'm done with this video now. I'll be giving Slackware a go for the season finale, but check back next week when I'm building a slightly dodgy ISA card from Plants in an Electronics Hobby magazine. Until then, thank you for watching.